Hello guys, today we are going to do hands-on on packet tracer, verifying IPv4 32 bits address and also IPv6 128 bits address. So this is presented to you by Dennis. So first of all, before we move on to our topic today, verifying the IPv4 and IPv6, we have to first understand the concept of the IP address. So IP address is simply a naming of a PC or a device in order for us to identify which device is which device. So without further ado, let's move on to our packet tracer. So in order for us to verify the IPv4 and IPv6 addressing, we can distribute the task into a few parts. So we have part 1, part 2, part 3. So part 1, complete the addressing table documentation. Part 2, test the connectivity using the ping command in the command prompt. And lastly, followed by the discover the path by tracing the route. So for the part 1 itself, we have our addressing table here, and then we fill empty spaces with which referring to the IP address of the PC1 and also PC2. So at the part 1, so we are going to use the ipconfig command in the command prompt to verify the IPv4 addressing, and also use IPv6 config to verify the IPv6 addressing. So in the set 1 ipconfig, we are going to click on the PC1, open up the PC, and then open up the desktop face, and then also go to our command prompt and then enter the command /o command to collect all the information and then fill it into our table. So okay, at our right side here, we have the packet tracer window, and then we have PC1 here, we have PC2 here, we have some intermediate device here. We go to our PC1, and then we go to our desktop, and then go to our command prompt. So in our command prompt, we are going to use our IP command, which is ipconfig, and then space /o. In this case, we use /o because we want all the details of the IP addressing. So in this case, we use ipconfig /o, and then we get our IP address, subnet mask, and also default gateway for IPv4. So this one is the IP address, this one is subnet mask, and also the default gateway of IPv4. So we are going to copy this information into our addressing table. Okay. So now we have copied our information into our addressing table for PC1. So now we're moving on to PC2. So same concept apply to PC2 as well. So we open up the PC2 and then go to the desktop face and then open up the command prompt. And then in the command prompt, we are going to use the IP command ipconfig and then /o. And then I obtain the IP address, subnet mask, and also the default gateway for PC2. Okay, so now same as PC1, I copy it into my addressing table. So now we're moving on to our step 2, which is verifying the IPv6. So use IPv6 config to verify IPv6 addressing on the PC1, and then enter IPv6 config /o command to collect the information and fill in the addressing table. So in this case, we open up our PC1 once again, and then we go below here, press your up arrow key to access your last entered command. We enter v6 in between of the IP and the config wording, and then we get our new command here, and then we have our IPv6 address and also its default gateway. So this same goes to the PC2 as well. So same concept, same method. So now I will copy the information into our addressing table. We move on to the PC2. same concept as well. We're going to use IPv6. So now I copy all the information into my addressing table. Okay, now we have done our addressing table for the part 1. So we're moving on to part 2. In our part 2, we are going to test the connectivity using the ping command in our command prompt. So we have step 1 and also step 2. So in our step 1, we are going to use IPv4 address, and step 2 using the IPv6 address with similar substeps. So subset A, we are going to ping PC1 to PC2 by using the IP address and see whether the result is successful. And for the subset B, we are going to ping the PC2 with PC1 using the IP address, and then let's see whether the result is successful. So same goes to the IPv6, just changing the IP address. So we open up our PC1 command prompt and also PC2 command prompt here, and we put it side by side for easier reference. And then I have pre-prepared the command to be run in the command prompt. So for the step 1, we involve IPv4, and step 2, we involve IPv6. And then for the PC1, so if let's say PC1 is going to be the host, and then the PC2 will going to be the destinations. So PC1 to ping the PC2, you have to use the ping command and then space in between, and then you are going to write down the destination's IPv4 address. So in this case, this IPv4 address belongs to PC2. So just like that. Okay, let's run for the step 1. Let's see whether it is successful or not. Okay, done for PC1 and done for PC2. I run it on the same time. Okay, so based on the result, both are successful, and then we move on to the step 2 with IPv6. So on the step 2, we are going to ping the PC1 to PC2 by using IPv6. So okay, same as the step 1, we are going to use ping command and a space in between. And then this is where you have to be careful, because somehow when lots of people when they try to copy, and then they copy the whole thing of the IPv6 address, and then they've forgotten to delete this /64. We have to delete this /64 because this one is actually stand for the prefix length of the IP address. So we have to cancel it. So now it's the correct format. So we copy it, and then we put it inside the command prompt. Okay, so run at both the same time. So as you can see, both are successful as well. So our part 3 are going to discover the path by tracing the road. And then we have step 1 and step 2, step 1 for IPv4 and step 2 for IPv6. So in our step 1, we are going to use tracer to trace the road from the PC1 to PC2 and identify what addresses were encountered along the path. And lastly, we are going to decide which interface are the 4 addresses associated with. So in this case, we have to open out the command prompt of the PC1. So once again, inside the command prompt, we must use the formula of traced, and then the destination IPv4 address, which is in this case is IPv4 of PC2. So the IPv4 of PC2 is 10.10.1.20, and then I press enter to trace the route from PC1 to PC2. And then in this case, we have obtained 4 addresses, and these 4 addresses will be the address encountered along the path. So in this case, before we go to decide which interface is associated with each of these addresses, we have to understand how many interfaces are there in the diagram between the PC1 to PC2. So in this case, PC1 have one interface, and then PC2 have one interface, and then we have 3 intermediate devices, and then inside the R1, R2, and R3 there are interfaces as well. So as you can see here, each interface is actually associated with a specific IP address, no matter it's IPv4 or IPv6. It's both specific, unique. So from our four encounter as address, we are able to identify which as interface is associated with them. So in this case, for the first address here, we have the 10.10.1.97 is associating with G0/0 under the R1 device. So for the next address, 10.10.1.5 is associated with the S0/0/0 under R2, and then next one is the 10.10.1.10 associated with the S0/0/1 under R3 device. And then lastly will be the interface of the PC2, which is the destinations of the road. And then that's all for the PC1 IPv4 road, and we are going to find the road of the PC2 as well later on. But before that, in order for you to prove that this interface is actually belongs to this device, and then this device contains the address of this IPv4, so you can actually check it through your diagram here. So for example, like R1 contains G0/0 interface, and then associate with the IPv4 address of 10.10.1.97. So you go in, you go to find the R1 device, and then you click on it, and then you go to the command line interface, and then you press enter, and then at here you are going to initiate the command of show IP interface, and then brief, because you doesn't want it to be very long, right? So you better use brief. So in this case, you are going to see the interface variable and the IP address here associated with it. So in this case, we have G0/0 interface associated with the IP address of 10.10.1.97, exactly the same with this in the addressing table. So that's why the segment is 2. So now we're moving on to our PC2. So let's see, is there any differences? So in our PC2, from our PC2, we initiate the trace command as well, trace it, and then the destinations, which is the IPv4 of PC1. So in this case is 10.10.1.100. Sorry, give it some times. Okay, so now it's all set. Okay, so these are the 4 address that encounter from PC2 to PC1 row. So for the first address, 10.10.1.17, it is associated with the interface of G0/0 here under R3, and then the next address, 10.10.1.9, is associated with S0/0/1 here under R2. So next one will be 10.10.1.6 associated with S0/0/1 under R1 device, and lastly will be the destination interface, which is PC1. So let's see, is it the same, having the same address 10.10.1.100, and then let's see here 10.10.1.100. yeah, it's correct. So the interface for the IPv4 for the PC1 and PC2 done, and then now we move on to the step 2, which is using the IPv6. So in this case, we just change the IPv4 to IPv6, and that's it. So same method, same command. So like this one, we use tracer and then IPv6 of destination, which is the 20001, and then okay, so this is the destination IPv6 of PC2. So this is the way of writing for the command tracer. So we have obtained 4 address for from the PC1 to PC2 format, and then for the first one we have 1.1.1, and then it is associated with the interface of let me see, so associated with the interface of G0/0. yeah, it is here. So the next one will be the this address, and this address 1.2.1 is associated with S0/0/0. So next one 1.3.2 is associated with okay, this one S0/0/1. So next one will be 1.3.2 okay, S0/0 and /1 as well. So lastly, it will be the destination PC, which is the PC2 2001 DB8148. So it's correct? Okay, correct. So now we move on to the PC2. Same things to do. Trace, cert, and then destinations, IPv6 address, which is 2001, and then DB8118. So it's correct, and then we trace it. We got 4 address as well. So the last address must be the destination address, which is the PC1, and then in that case we start from the bottom first. So since the last one will be the interface of the PC1, and then we skip it, so we have the third address 1.2.2. so it is associated with okay, it's associated with S0/0/1, so under R1 device. And then next one 1.3.1 is associated with okay, 1.3.1 is associated with S0/0/1, so under R2 device. So nextly we have 1.4.1. we have it associated with the interface of G0/0. So these are all the interface associated with these 4 address encountered along the path from PC2 to PC1. So I think that's all for the topic of verifying the IPv4 and IPv6 addressing in the packet tracer. So hope you guys enjoyed this video and have a nice day. Bye.